get into this? Anybody have general questions? Yes.
So, you know how val is unchangeable?
Yes.
But if the value of val is var, is reference to var, and you change var, the value of val is changed too, right?
If okay, I got to wrap my head around this one.
Right,
So
val is reference to var.
So if val has a reference to an object, and that object has a state variable of var, is that what you're saying? Yeah.
And if you change var, val is changed too. So my question is there a way to be like value fixed, unchangeable at all?
Excellent question. Not quite. Not like say val, nothing in this object can change. There's no functionality like that. If you want that functionality, so one, the val of the object, that value stored in that variable is a reference to that object. That reference never changes, so that val isn't violated. But that reference points to an object on the heap, and if that object on the heap has vars, those can change, but what was stored in that value was just the reference, which didn't change, even though the values that reference of the object that reference refers to did change. If we don't want anything to change, we would have to make those val inside the object as well, which would have that effect in the class, and that would have that effect throughout all objects of that type. If we just want one object where the values can't change and the rest var, we don't really have the means to be able to do that. That would have to, we wouldn't have that functionality. We'd have to create another class where those are vals instead of vars. Do you have an application where you want to do that? I'm just curious.
Like your question?
So it'll never hurt you to have everything, for lecture questions, for grading in the course anyway, to have everything var, and then you just don't change them. When you want to use val, that's when you're more communicating to other developers that this is something that if it changes, it's probably going to break a lot of things. It can also help you if you know that shouldn't change. You can use val, and then the compiler will say, hey, you told me this wasn't going to change, and you tried to change it. And you can go, oh, whoops, and then fix that. And it also helps the compiler to have more efficiencies. It can say, okay, I know that's never going to change. I can optimize this a little better. For your assignments, you wouldn't have to set it as val. Just you yourself know, don't change those things. If that makes sense. Is that good?
Yeah.
Does that make sense? Okay. Any other questions? Yes?
In the physics engine homework, when you're looking at the dynamic object class, for example, it says that that class extends to the game object class. So
Yes.
does that allow it to be referred to as two types? Because when you're making the is collision method, that's for game objects, but you're for the dynamic object in there.
Right. And this is a question for next week. So I should preface this. I think I might have put it in the doc somewhere. I might have forgot. But a lot of the code in the physics engine homework you don't have to understand. Most of that, there's no expectation that you understand that code. But I'll give you a quick answer. We'll talk about this at length next week. But the dynamic object class extends the game object class, which means anything of type dynamic object is also of type game object. Did I say that right? Dynamic object and game object. If I have a dynamic object, it's also game object. If I have a variable or a value of type game object, I can put dynamic objects in that variable. I can store references to dynamic objects in that variable or value. And it also extends all that functionality. It grabs all the functionality from the game object class and adds that to the dynamic object class.
So the dynamic object class is still unique from game object, but they're able to, the dynamic object class shares game object as well. It's not, it's like one way, it's not.
Yeah, it's one way. So game object knows nothing about dynamic object or static object. It's a one-way inheritance. There's also a lot of stuff in the physics engine homework about states. The player, the way the jump mechanic works for each player uses the state pattern. So if you are interested in looking ahead at that, take a look at that. But that's not for, my goodness, that's in 2 weeks already? This semester goes fast. But in 2 weeks, we'll talk about the state pattern. So if you want to get ahead and take a look at an example, the physics engine has an example. But there's no expectation that you can understand that yet. All the inheritance, polymorphism, the state pattern. It's all in that homework in the handout, but you only need to worry about the physics engine and implementing that functionality from the assignment. So if you open Physics Engine, we're intimidated by all the files in the jumper game. Just know that you don't have to really look through all that. So today's lecture is going to be a lot of live coding. We had 2 good questions already. Keep them coming as I'm coding. If you stop me and want me to explain something, want me to show more different things, you want me to switch it up, it's all live. I don't know exactly what I'm going to code anyway. So if you say, hey, can you do it some other way, I'll be happy to do that. So by all means, ask questions throughout today's lecture. There's not necessarily new material today. It's reinforcing, reviewing the content of the past 2 weeks. So if there's something that doesn't make sense, now's the time to slow down, digest, ask me specific questions on the code and the examples. To that end, we want to get this lecture question today. I know it's a lot of text, but a lot of this is mostly cut and paste between these 2 classes. So this is similar to the last lecture question, but expanding it a little bit. We have a battery class. We want 3 classes. Battery class, similar to the valuable class last time, except we do have some state in this battery. I want to be able to create batteries with some charge. It's going to take that charge as a value in its as a variable in its constructor of type int. As with the other questions, charge, it's named. The name is clearly defined in quotes here. That means in your testing, you can access the variable charge. You can check that in your asserts. So charge, so we create batteries, they have some charge, and as we use these batteries, it's going to deplete the charge. A boombox class that takes a battery in its constructor, named battery, so again, you can access this battery through that variable name. We'll have the same variable names in my code, in your code, so you can test that variable in your test suite. It's going to take a battery in the constructor, so I have a boombox, but I have to provide a battery to be able to run this thing. And I can put that battery in the boombox when I create it. A method use, this is where, of course, the boombox will play music and things. We're not going to have the functionality, we're simulating this, but we are going to have the battery drainage. So whenever we call use on a boombox, whatever battery is currently in its state variable, whatever battery is currently in this boombox, it's going to drain 3 units of charge from that battery. So we need to decrease that charge of that battery by 3. If the charge is less than 3, this does nothing. So if I have a battery with charge 2 inside this boombox and I hit play, I want to run this boombox, nothing happens, boombox doesn't play, the battery doesn't deplete down to 0, it stays at 2. Then, so some functionality, the big one we want to focus on, the one that is going to handle references, is replace battery. This method takes a battery and returns a battery. I have a boombox, it has a battery in it. I have presumably a dead battery, and I have presumably a fresh battery that I want to put in the boombox. Replace battery is going to take that battery from the parameter, put it in the boombox, remove the other one, and then return the battery that was in the boombox. And we want to make sure this all happens by reference. We want to make sure it's not the battery that's in the boombox after this method is called has the same charge as the battery of the parameter, and the returned one has the same charge as the one that was in the boombox. We don't just want to check the charge, we want to make sure these are the exact same battery, and we're going to do that by checking their references. Did we actually swap these physical batteries that we're simulating? Did we actually swap these batteries, or was there some magic, new batteries created out of thin air with the same charge? We don't want any of that. We want to actually swap these by reference. Then another class, flashlight, a lot of the same functionality, except the batteries are included in flashlight. Constructor takes no parameters, and when you create a new flashlight, create a new battery in its state variable. We got named battery, so we can access, just like the other battery, we can access this in our tests, and that battery should have a charge of 5. So when you say new flashlight, that flashlight is going to create a new battery with 5 charge in it. When we use the flashlight, it's going to use up 1 charge. If the charge is 0, does nothing. And technically, a negative charge should also do nothing, but we're going to assume that we're using these properly. We don't have any such thing as a negative charge. But technically, either of these would do nothing if you happen to create a battery with negative charge, would be the expected behavior. So 0 or less does nothing and doesn't deplete the battery. And then replace battery, which is the same exact thing as replace battery in the boombox class. Then the testing making sure that replace battery is swapping by reference. It's one of the things we want to talk about. Very similar to Wednesday's question, we want to make sure the traders are trading valuables by reference. Did they actually trade those valuables? How do we tell? We're going to use that equal to compare by references. And the second example in the live coding, I'll show examples of exactly what that looks like, what it looks like when we do it the wrong way, and how to fix it and do it the right way. Question?
Yeah, so for the boom box replace battery function, the input and the replace battery should be replacing one in the constructor, right?
Correct. It should be replacing whatever's in that variable at that time. So we call the constructor and we'll give it a battery. That's going to be stored in that state variable named battery. We might call replace battery and swap that out with a new one. So then the next time we call replace battery, it might not be exactly the battery that was called with the constructor, but it'll be whatever battery stored in that variable named battery at that time. Does that answer your question? Does that make sense? So like when we call replace battery with a battery in the parameter, this battery in the parameter needs to end up in this battery variable. And whatever was in this battery variable needs to be the returned battery here. And that has to be the exact batteries by reference.
Wait, so are we creating a new battery? Like, it's not.
In your testing, you'll create new batteries.
Yes.
In your methods, no. The only place you're going to create a new battery in your code itself, outside of your testing, is when a new flashlight is created. Outside of that constructor and outside of any of the methods, you're going to create that state variable, var battery of type battery equals new battery of 5. Not to give away the answer on that one, but I'm really concerned with the replace batteries and the swapping of references, so I don't mind leaking that one. Okay, lecture is going to be live examples, then we're back to the lecture question. No slides today. All right, so we're going to revisit some code that we wrote a while ago. Go back to our live coding project. And take a look at this anagrams. Ooh, didn't make that change I wanted to make. I just want to move this. This is the one change I want to make to the code. I want to put that conditional up a little higher. So this is the code to compute anagrams. We'll step through this in the debugger, so we won't go line by line right now. But let's go to our tests. Actually, I do want to go line by line right now. So we want to, given an input string, compute all the anagrams of that string, which is all of the strings that can be made by rearranging the characters of the string. I'm going to store those in a list named output, or a variable named output of type list. I'm going to end up returning this. If the length is 1, I'm just going to return a brand new list. Actually, technically, this could go, let's not bother. If the length is 1, I'm going to return a new list with that input. If I have a string of 1 character, it is itself its only anagram. You can't rearrange one letter in any way. Let's just return that list, a list with that input. Else, we're going to iterate through the characters of the string, remove the characters one at a time for each iteration of this loop, compute the string with that character removed, compute all the anagrams of that string with the with that character removed, and then iterate through those anagrams and append to our output all those anagrams, but with that character added back in. So we're going to compute all the anagrams of that substring, get all those anagrams, append this character that was removed to all of them, and then do that for each character. We should get all of the anagrams of the original string. So let's go to our tests. And we didn't quite get to, you know what, let's add that quick. So we had the issue with duplicates in here. We didn't quite get to finish that in this lecture. So let's just quickly add that. So I want to check this word that I'm trying to add. If I only want to add this word if I haven't already added it. So if the output does not contain to add, then add it. So if it's already in the output, don't do anything. But if this word is not already in the output, add it to the output. So I'm just doing a quick check. Is it in there already? If it is, do nothing. If it isn't, add it. So I'm only adding each word once. No duplicates anymore. Now, I want to set a breakpoint in my testing and be able to see what's going on when each one of these test cases are called. So let's set a breakpoint right here, right before a method is called, and see what's going to happen throughout the execution and how it's going to run. So I'm going to right-click and debug, and we can do debugging from our test cases just like we can from a main method or any other full program. Just set a breakpoint and debug. It's going to take a while to compile, but once we get there, first thing we're going to notice when we run a test, this isn't too critical to know, but a little factoid, I guess. There are tons of frames on the stack. So this is all the overhead of our unit testing. Scala test puts a lot of frames on the stack. It's doing a lot of work behind the scenes before it even gets to the point where it's calling our code. So you can, if you're ever interested, you can look through what it's doing. But eventually, way back here, can I go to that code? I tried to do this in the other lecture. I couldn't get there. I tried it a different way, though. But we can see we do have a main method at some point. Scala test runner is the object that we're running the main from. And then way down this road, it calls a lot of other methods. Finally gets to our stuff. And the first test case we have is A. Just happens to be a map. The order isn't necessarily preserved. Key value pairs, there's no sense of ordering. But we did happen to get A as the first one. So we have the input A. Expected output is the list containing just A. And let's start stepping through our code. Create a new output list, which we actually don't use. Input.length, our input is A. Length is 1, true. Return a list containing just A. Check if the list containing just A is equal to the list containing just A after sorting. That's going to be true. We're going to get into a whole bunch of other stuff. Change the step out of button. That's going to take me out of the current method. I don't really care what's happening with the assert method call. So I'm just going to step out of that. Step out. And get to our next test case. Actually, I could show off this button. I'm going to resume. That's going to run the program until it hits my breakpoint again. So it's an easier way to stop. Now we hit our next test case, a more interesting one. We're actually doing some computation. CSE. I expect the output to be all of these anagrams. And let's see what our method does on this input. A little more interesting. We actually get to see the recursion going on here. So let's step through. We create our output, empty list. Condition is false. Start with the first character. We're going to grab that character and create a new string. And we can see as we're executing that our program's doing what we expect it to do. We're taking the character C off of this is the first character we're removing. Our new string is SE, the CSE with the C removed. And then we're going to call anagrams on SE, the string SE. That's going to put another frame on the stack. And we can go back to our other stack frame. We can see where we are. We're right here at this call with CSE as the input, with the empty list being our output, with SE being the new string that we're calling anagrams with. And then on this stack frame in that call, this is where we are with the execution. We're checking our conditional. It's false because our input is SE. We're going to remove the S. We're left with E. Have our recursive call. It's just E. We're going to return the list with just E. And now we get to the part after our recursive call for the first time. Right now the input is SE. Our output is empty list. Our new string, our anagrams of the new string is just E, and the character removed was S. So we're going to append S to the end of E and add that to our output list. So to add is ES. Is it in the output? No, so we're going to add it. End of that iteration. And now we're at the next step our next iteration of this loop with I equals 1 in this loop. Now we're going to remove that character E, our input SE. We removed S, had E, and got that in our output list. Here's our output. Let me expand that. And we got ES in there. Now we're going to remove the S, have a recursive call to E, and end up appending S to the end of that. So let's make sure that execution is going the way we expect. S, just return S, append E, to add is SE. We're going to add that to our list. Why can't you find local variable anagrams of new string? And we're going to output this list of size 2. Our input was SE. We're returning SE and ES in that output list. So we have all the anagrams of SE. Now we're at the end of this stack frame. This stack frame is going to go away. We're back to the stack frame where our input was CSE. We just went through quite a good number of recursive calls. We're back to this stack frame. It was waiting for anagrams to return after we removed C from CSE and called the anagrams of SE. We have our anagrams of that new string, and we want to append C to the end of each of these to get our new anagrams. And at this point, I could have mentioned this at any time, but I want to talk about it right here. So SE, we're going to add that C to the end to get this first one. If we look at this, actually I want to go one more. So we're going to add SEC, our first value added to the final output on our top level recursive call, SEC, our first anagram that we finally got of length 3. But if we look at our output list, we can see the references as we go through here. So we see stack frames getting put on the stack, but we can also see the references. This output list, the variable named output of type list, currently refers to a list that's at 2032, which is some reference which is going to tell us where to find this list. When I add a new item to this list, so we're at 2032, we're going to add ESC to this list, and now we're at 2038. We have a brand new list. We do have to have this list as a var because we just replaced the reference with a new list. When we said, let me rearrange this a little bit. Get rid of my shorthand here so we can explicitly see what's going on. This is the more drawn out way of saying it. This is the more clear way of writing that. We're taking that output list, appending this new word to it, and that creates a brand new list. The list in Scala, this is immutable. We can't change it. So when we add this to the list, we're actually creating a brand new list and reassigning the reference of that new list to the output. So we actually changed the reference that output refers to when we added that element to that new list. We created a brand new list, returned a reference to the new list, and stored that reference in our output variable. So that original list of size 1, it's gone. We don't have access to it anymore, but we do want this new list of size 2, and we replace that reference to get that new list. And we can keep going. I don't have anything more interesting to talk about. It's just more of the same. This will keep going through the letters. It'll remove S from CSE. We're removing S from CSE, recursively calling this on CE, and going through each letter one at a time. All right, any questions or anything you want to see with this example? Before we get to the next one? Okay. And the big takeaway today maybe I didn't make it, I didn't give a good intro to the takeaway is run the debugger, please. It makes it so much easier to debug your code. When you can actually see all of the variables, you can see the references, you can see the stack, you can see everything that's going on in your program, and it can make it so much easier to debug things instead of trying to add in all those print statements or running main methods or whatever you're doing to test. Just set a breakpoint wherever you think there might be an error, run the debugger, take a look at all of your variables and all of your references, and see what's going on with it. So with that, let's get to, a reminder, I gave this reminder to the other section. I gotta do this in all three. Just a reminder, I said this last time, the lecture questions, I can really test the first two bullet points for this learning objective, testing, references. But the third one, the stack and heap, I can only really test that in lab. So you can count on lab next week. The activity is going to be, here's some code, here's a breakpoint, draw me the stack and heap, as you can expect. So we went over that a bit in lecture, but I can't hit you with the lecture questions with that. Lab next week, be ready, know those stack and heap diagrams, be ready to draw those. So that's where that's really our only chance to hit that third bullet point. That and the TA interview, that's the only time we can hit that third bullet point. So that's what I'm gonna be looking at to assess that third one. Just be sure, be plenty warned about that one. Be ready for it. So let's solve this problem. I got a problem here, I wanna solve this, how do I do it? So we want a player, thinking about the jumper game for the physics homework, I want a player that can manage inventory, pick up items, and drop items. I want this functionality from a user. To that end, first I need a GameItem class. This class, same idea as the valuable class from Wednesday, same idea as the, forgot what I called it, the something from today's lecture question, the top one. It's bugging me, I gotta check. The batteries, yes, the batteries. The batteries from today's lecture question. We have a class, it's going to take a string as a value, as for the description of an item. We don't expect the description to change, so I'll set it as a value. And that's it, that's the entire class. So let's write that class real quick. Scala class, GameItem, constructor takes a value named description of type string. And whenever I have something like this, where I have a question, has a specific name, cut, paste. Now I know I'm not going to get any crazy issue where I got one character off, one character missing. I'm not going to have to squint at that and then the problem description and make sure I have it right. Cut and paste, super easy. Do that, download the slides, pull up your slides, grab that, anything in quotes, paste it into your code. Make sure you get the spelling right. I see these in office hours and on Piazza still quite a bit. It's one of the most frustrating errors. I feel the pain every time this happens. If you cut and paste those variable names, those method names, those class names, you can save some headaches with those ones. Trying to chase down the exact spelling, exact character for a string. All right, so that's it. That's the GameItem class. That's all there is to it. The battery class, same thing, except an int. Very not much functionality going on there. The whole idea is that we want to move those around by reference and work with those in references. Next, we need a player class. We're not gonna do anything with the physics engine stuff. We won't have time to get there. But this should have the location and dimensions just like the physics engine homework. So location can change. So that I want a var. Dimensions, not so much. We'll have that constructor where it can have a location and dimension. Let's get to picking up objects. Pick up item. Takes the game item. returns unit. Drop item by description. Description is a string. Returns game item. And for now, I'll just set that to null so we can implement pickup item first. And I want this to be what it implies. I want to be able to pick up game items, add them to my inventory, and then drop game items. They should be removed from my inventory. And I want to make sure that this game item that I return is the same game item that I picked up by reference. It has to be the same exact item. I don't care if it's an item with the same description. I need it to be the exact same item. So with pickup item, first we need some way to be able to track our inventory. It's going to change, so it's going to be a var. I'll call it inventory. I'm going to use a list of game item. So I'm going to store all my game items in a list. When I pick up an item, this.inventory prepend item. Now I need some testing too. So before we get to drop item by description, I want to start testing and do my testing in parallel. There are arguments for when to test. There are heated debates around the software development industry. The kind of natural thing that we all start off doing is test after you write the code. It's not always the best strategy, but it's kind of the one that flows naturally for us. We can do what I'm doing, kind of testing in line as I write. I write a piece of functionality, test it, write, test, write, test. I kind of like that. I just have a preference for it. There's also some strong arguments, and some of my colleagues really, really strongly push this, is test-driven development, where you write your tests first, write all the tests for all the functionality, and then write your implementation, your code after. So I'm not going to be strict on when you write your tests. I just want you to have those tests. But writing your tests first can have some strong benefits. Writing your tests after, you can't leverage those tests to help you write your code. There are some downsides to that. But I kind of like to do a hybrid of the two. So let's start the tests with that. Test player. I'm going to copy this so I have my boilerplate. Oops. So I don't have to get all the setup for a test. Test player, change the name of my test. Then I can delete all this. I want a player. We're not going to mess with the physics vector stuff, so I'm just going to give it 2 default vectors. And that's using this physics vector class. 3-dimensional vector, x, y, and z all default to 0, and then I have a little toString to be able to print it out. So let's, oh my goodness, create a new player class. 3 p.m., make sure I got the right player. I want to pick up an item, new game item. What should we pick up? A bow. Let's go with a sword. I'm going to pick up a sword, I guess. And then I want to assert, we won't check anything complex right now, we're just going to assert that p1.inventory.length is 1. I just want to make sure that I have a sword, something in my inventory after I pick up that sword. So we're not really testing all the functionality yet. Just want to know, did something make it into the inventory? Is this going to pass? It should. I'll go with that. It should. But it doesn't. Expected length 1 actually got 0. So here, when we start, so I got to test, it fails, I don't know what's going on. So let's set a breakpoint, run the debugger, and figure out where our mistake was here. Where did I pull one over on you and have something that doesn't quite work here? So let's run the debugger. When we first hit our breakpoint, I can first check P1. Okay, physics vectors are zeros as we expect. The inventory, that's just an empty list. At 1648, step through, create a new game item. Have a game item with a description sword. I'm going to append that item to the inventory. And then my inventory is still nil, still 1648. I never reassigned that reference to the list. This is one of the things that takes a little bit to get used to when we start working with Scala. I never reassigned this to the list. So I created a new list, which was the empty list with this item, this sword, prepended to it. But I never did anything with that reference. I just left it on the floor, walked away, never stored it in any variable, so that new list never had any effect on my program. What I need to do is replace that reference. Let me rerun the debugger. And this is specifically because lists are immutable. We can't change a list in Scala unless we use the mutable list, which we're not doing because immutability is a big topic later in the semester. I want to get you used to it. So now when we hit the pickup item method, when we return, we do in fact have that sword in this list. And we have a different list. I didn't check the reference of the empty list, but trust me, it's a different reference than that empty list was in this call. And if we resume this, it's going to run till it hits another breakpoint. There are no breakpoints, so it just runs till it ends. Test passed. So we have items being added to our inventory. We didn't fully test pickup item, but let's, we're not going to have time to fully test this thing, but let's get to drop item by description. Here's an item description. Drop one of your items with that description. There are multiple items, just drop one. So first we know var, and if there's no items of that description, create a new item with no description and return that was part of the problem statement. We'll do fancier things later in the semester. For now, we just want something to be able to return something without returning null, which is not a Scala way to do things, to say it lately. So we're going to return something. We're just going to return an empty description. So let's default what we're going to return. To return, type GameItem equals new GameItem. Let's default to empty string, so if we don't find an item with this description, we're just going to return this thing. If we do find an item with that description, then we're going to swap out, we're going to reassign to return to that item that we found. So let's iterate through our inventory and look for an item with that description. So for item in inventory, if item.description equal the description that we're looking for, that's our item. Right. To return equals that item. Then if to return dot description not equal empty string, you can do this. This dot inventory equals this dot inventory. I'm gonna cheat. Diff. This is the gross way I did it in the morning lecture because I couldn't think of how to do it. So I almost made sure that I knew how to do it this time. diff list of to return. So this is going to remove that list of, it's going to remove that item to return. If you didn't know how to do that, don't feel bad. I didn't know how to do it in the 1 p.m. Removing from list just isn't something I find myself having to do very often. So I completely blanked on it. I came up with that hacky solution that you saw in the other one, but I looked it up. Diff is the way we can do that. So, and then we'll return to return after updating our inventory. So now let's go back to our test and see if this works. So we don't know if this is going to work yet. Val returned item equals P1 dot drop item by description sort. Assert returned item dot description equals sword. We'll run our test. Is this going to pass? Sure does. But we don't quite have the functionality, or we didn't test the functionality that we want to test though. So this, we did return the item that we're removing, but what if instead of returning to return, we return a brand new item with the same description? How are we going to tell that we're actually returning the same exact item, or if we're just turning an item with the same properties, with the same state variables, with the same values in those state variables? So this is wrong. We can't do this. We can't return a brand new item, create it out of thin air, and just give it the same description and return it. I mean, we can try, but but it's not really the right thing, not the correct thing to do for this problem statement. But how do we test for that? How do we make sure that we're not doing that in our test suite? How do we check for that? So for that, we want to check this by reference. So we want to take the item itself, that reference that's stored in variables of type GameItem, and check that reference to see if it's the same reference as before. Does this refer to the same exact object? We can use equal equal for that. So for that, we need to have a reference first. So I'm going to pull this out, create a value named sword, store that reference to the new game item that I'm creating, then have the player pick up that item that I still have a reference to. So I gave the reference to this player, but I still have a reference to that sword as well. And then when I get this returned item, I can make sure that it's the same sword. And now we should get our test failing. We should say, hey, you're returning a brand new sword out of thin air. That's not allowed. And we can run our debugger. We can see what's going on. We can read the references don't match down here. Or we can run the debugger, walk through this thing. Player has an inventory of size 1, has this game item, 1636, description sword, 1636 of description sword in our variable named sword. So we have the correct item in their inventory, but then when we call drop item, we're going through the inventory, finding that item. Inventory is now empty. We removed it from their inventory. We have it into return, but then we create a new game item. And that returned item, it's a different sword, it's a different item. These references don't match, even though their descriptions are the same. In fact, they're the same reference, it's the same exact string. But the game items themselves are different. These are two different swords, even though they have the same value. They're two different references. We can't allow that. When we return, we need to return that item by reference. We're not creating a brand new one. Let's stop this, run, and we should be passing that test now. Return it by reference. We want that specific item, not just a new one with the same properties. And then we would make sure that we can handle more items. Let's add a potion. Ball. I don't know what kind of game we're playing, but we have a potion, a sword, and a ball. This length should be 3. And we would add a lot more testing here, but let me just run through the debugger, and we can see that what we have, all these items that we have in our inventory. I can look through the code as we're running it. Look through the values as we're running it to see if I have what I expect to have. So I have my 3 variables. I have my player inventory has that ball, potion, sword. All the references match up. Oh, I didn't zoom in. All the references match up. I have the same references all the way down. This inventory does store the items that I gave it, not copies of those items with the same description. When I look through for a description, I'm looking for a sword. Checking the references, checking the descriptions at those references. Finding the sword. To return is at 1636. That 1636, which is a sword. Removing it from the list. This is the new thing, we didn't check this yet. But making sure that that sword is removed, that's the sword removed. Then returning that sword, asserting that it's true. Getting all the right values there. Then we'd have to, for comprehensive testing, we'd have to add 2 items with the same description, make sure we don't remove them both and things like that. We'd have to add to get our comprehensive testing. But that's how we would use the debugger. Highly recommend it. Use the debugger. It'll save you hours of your life. Please do it. Have a good weekend. I'll see everyone Monday.